I decided when I was asked to do this that what I really wanted to talk about was my friend Richard Feynman. I was one of the fortunate few that really did get to know him and enjoyed his presence. And I'm going to tell you the Richard Feynman that I knew. I'm sure there are other people here who could tell you about the Richard Feynman they knew, and it would probably be a different Richard Feynman. Richard Feynman was a very complex man. He was a man of many, many parts. He was, of course, foremost a very, very, very great scientist. He was an actor. You saw him act. I also had the good fortune to be in those lectures up in the balcony. They were fantastic. He was a philosopher. He was a drum player. He was a teacher par excellence. Richard Feynman was also a showman, an enormous showman. He was brash, irreverent. He was full of macho, a kind of macho one-upsmanship. He loved intellectual battle. He had a gargantuan ego. But the man had somehow a lot of room at the bottom. And what I mean by that is a lot of room, in my case, I can't speak for anybody else, but in my case, a lot of room for another big ego. Well, not as big as his, but fairly big. I always felt good with Dick Feynman. It was always fun to be with him. He always made me feel smart. How can somebody like that make you feel smart? Somehow he did. He made me feel smart. He made me feel he was smart. He made me feel we were both smart, and the two of us could solve any problem whatever. And in fact, we did sometimes do physics together. We never published a paper together, but we did have a lot of fun. He loved to win. When these little macho games that we would sometimes play, and he didn't only play them with me, he played them with all sorts of people, he would almost always win. But when he didn't win, when he lost, he would laugh and seem to have just as much fun as if he had won. I remember once he told me a story about a joke that the students played on him. They took him, I think it was for his birthday, they took him for lunch, and they took him for lunch in to a sandwich place in Pasadena. It may still exist, I don't know. Celebrity sandwiches was their thing. You could get a Marilyn Monroe sandwich, you could get a Humphrey Bogart sandwich. The students went there in advance, and they arranged that they would all order Feynman sandwiches. One after another, they came in and ordered Feynman sandwiches. Feynman loved the story. He told me the story, and he was really happy and laughing. When he finished the story, I said to him, Dick, you know, I wonder what would be the difference between a Feynman sandwich and a Susskind sandwich. And without skipping a beat at all, he said, well, a Susskind sandwich, they'd be about the same. The only difference is a Susskind sandwich would have a lot more ham. Ham as in bad actor. Well, I happened to have been very quick that day, and I said, yeah, but a lot less bologna. The truth of the matter is that a Feynman sandwich had a load of ham, but absolutely no bologna. What Feynman hated worse than anything else was intellectual pretense, phoniness, false sophistication, jargon. I remember sometime during the 80s, the mid-80s, Dick and I and Sidney Coleman would meet a couple of times. We met a couple of times up in San Francisco at some very rich guy's house, up in San Francisco for dinner. And the last time the rich guy invited us, he also invited a couple of philosophers. These guys were philosophers of mind. Their specialty was the philosophy of consciousness. And they were full of all kinds of jargon. I'm trying to remember the words. Monism, dualism, categories all over the place. I didn't know what those things meant, neither did Dick, and neither did Sidney for that matter. And what did we talk about? Well, what do you talk about when you talk about minds? There's one obvious thing to talk about. Can a machine become a mind? Can you build a machine that thinks like a human being, that is conscious? We sat around and we talked about this. We, of course, never resolved it. But the trouble with the philosophers is that they were philosophizing when they should have been scientificating. It's a scientific question, after all. And this was a very, very dangerous thing to do around Dick Feynman. Feynman let him have it, both barrels, right between the eyes. It was brutal. It was funny. Ooh, it was funny. But it was really brutal. He really popped their balloon. But the amazing thing was, after Feynman had to leave a little early. He wasn't feeling too well. So he left a little bit early, and Sidney and I were left there with the two philosophers. And the amazing thing is, these guys were flying. They were so happy. They had met the great man. They had been instructed by the great man. They had an enormous amount of fun having their faces shoved in the mud. And it was something special. I realized there was something just extraordinary about Feynman, even when he did what he did. Dick, he was my friend. I did call him Dick. Dick and I had a little bit of rapport. I think it may have been a special rapport that he and I had. We liked each other. We liked the same kind of things. I also liked the kind of intellectual, sort of macho games. Sometimes I would win. Mostly he would win, but we both enjoyed them. And Dick became convinced at some point that he and I had some kind of similarity of personality. I don't think he was right. I think the only point of similarity between us is we both like to talk about ourselves. But he was convinced of this, and he was curious. The man was incredibly curious, and he wanted to understand what it was and why it was that there was this funny connection. And one day we were walking, we were in France, we were in Les Ouches, we were up in the mountains, 1976, we were up in the mountains, and Feynman said to me, he said, Leonardo, the reason he called me Leonardo is because we were in Europe and he was practicing his French. And he said, Leonardo, were you closer to your mother or to your father when you were a kid? And I said, well, my real hero was my father. He was a working man, had a 5th grade education. He was a master mechanic, and he taught me how to use tools. He taught me all sorts of things about mechanical things. He even taught me the Pythagorean theorem. He didn't call it the hypotenuse. He called it the shortcut distance. And Feynman's eyes just opened up. He went off like a light bulb. And he said, you know, he had had basically exactly the same relationship with his father. In fact, he had been convinced at one time that to be a good physicist, that it was very important to have had that kind of relationship with your father. I apologize for the sexist conversation here, but this is the way it really happened. He said he had been absolutely convinced that this was necessary, a necessary part of the growing up of a young physicist. Being Dick, he of course wanted to check this. He wanted to go out and do an experiment. So, well, he did. He went out and did an experiment. He asked all his friends that he thought were good physicists, was it your mom or your pop that influenced you? And to a man, they were all men, to a man, every single one of them said, my mother. There went that theory down the trash can of history. But he was very excited that he had finally met somebody who had the same experience as with his father, with my father, as he had with his father. And for some time, he was convinced this was the reason that we got along so well. I don't know, maybe, who knows. But let me tell you a little bit about Feynman, the physicist. Feynman's style, now style is not the right word. Style makes you think of the bow tie he might have wore or the suit he was wearing. There's something much deeper than that. But I can't think of another word for it. Feynman's scientific style was always to look for the simplest, most elementary solution to a problem that was possible. If it wasn't possible, you had to use something fancier. But no doubt part of this was his great joy and pleasure in showing people that he could think more simply than they could. But he also deeply believed, he truly believed, that if you couldn't explain something simply, you didn't understand it. In the 1950s, people were trying to figure out how superfluid helium worked. There was a theory. It was due to a Russian mathematical physicist, and it was a complicated theory. I'll tell you what that theory was soon enough. It was a terribly complicated theory full of very difficult integrals and formulas and mathematics and so forth. And it sort of worked, but it didn't work very well. The only way it worked is when the helium atoms were very, very far apart. The helium atoms had to be very far. And unfortunately, the helium atoms in liquid helium are right on top of each other. Feynman decided, as a sort of amateur helium physicist, that he would try to figure it out. And he had the idea, a very clear idea, he would try to figure out what the quantum wave function of this huge number of atoms looked like. He would try to visualize it, guided by a small number of simple principles. The small number of simple principles were very, very simple. The first one was that when helium atoms touch each other, they repel. The implication of that is that the wave function has to go to zero, has to vanish when the helium atoms touch each other. The other fact is that the ground state, the lowest energy state of a quantum system, the wave function is always very smooth, has the minimum number of wiggles. So he sat down, and I imagine he had nothing more than a simple piece of paper and a pencil, and he tried to write down, and did write down, the simplest function that he could think of, which had the boundary conditions that the wave function vanishes when things touch and is smooth in between. He wrote down a simple thing. It was so simple, in fact, that I suspect a smart, really smart high school student who didn't even have calculus could understand what he wrote down. The thing was that that simple thing that he wrote down explained everything that was known at the time about liquid helium, and then some. I've always wondered whether the professionals, the real professional helium physicists, were just a little bit embarrassed by this. They had their super powerful technique, and they couldn't do as well. Incidentally, I'll tell you what that super powerful technique was. It was the technique of Feynman diagrams. He did it again in 1968. In 1968, in my own university, I wasn't there at the time, but in 1968, they were exploring the structure of the proton. The proton is obviously made of a whole bunch of little particles. This was more or less known. And the way to analyze it was, of course, Feynman diagrams. That's what Feynman diagrams were constructed for, to understand particles. The experiments that were going on were very simple. You simply take the proton and you hit it really sharply with an electron. This was the thing that Feynman diagrams were for. The only problem was that Feynman diagrams are complicated. They're difficult integrals. If you could do all of them, you would have a very precise theory, but you couldn't. They were just too complicated. People were trying to do them. You could do a one-loop diagram. Don't worry about one loop, two-loop. Maybe you could do a three-loop diagram, but beyond that, you couldn't do anything. Feynman said, forget all of that. Just think of the proton as an assemblage of a swarm of little particles. He called them partons. He called them partons. He said, just think of it as a swarm of partons moving real fast. Because they're moving real fast, relativity says the internal motions go very slow. The electron hits it suddenly. It's like taking a very sudden snapshot of the proton. What do you see? You see a frozen bunch of partons. They don't move, and because they don't move during the course of the experiment, you don't have to worry about how they're moving. You don't have to worry about the forces between them. You just get to think of it as a population of frozen partons. This was the key to analyzing these experiments. Extremely effective. It really did. Somebody said the word revolution is a bad word. I suppose it is, so I won't say revolution, but it certainly evolved very, very deeply our understanding of the proton and of particles beyond that. Well, I had some more that I was going to tell you about my connection with Feynman, what he was like, but I see I have exactly half a minute. So I think I'll just finish up by saying I actually don't think Feynman would have liked this event. I think he would have said, you know, this is, I don't need this. But how should we honor Feynman? How should we really honor Feynman? I think the answer is we should honor Feynman by getting as much bologna out of our own sandwiches as we can. Thank you.